Welcome to chapter 25 on geometric optics. This is the second section where we're going to be working with basic reflections. To begin that, we're going to start with a simulation, which I already have pulled up. Here it is. Let me reset it for you so that you don't have to look at what I was doing before playing. So we're going to start with a light ray. Here it is, following a nice straight line as it should for geometric optics. And what we're going to do is we're going to just add a flat mirror. So here is our flat mirror. And look at it reflect. Does it surprise you that the angle it reflects at is roughly equal to the angle that it encountered the mirror at? Now, one thing that is odd about optics is we don't measure our angles from the surface. Instead, what we do is we measure from the normal to the surface. Okay, remember normal when we dealt with forces meant perpendicular. So what we're going to do is we're going to drop a perpendicular line to the surface at the location where the light ray encounters the surface. To illustrate that, I'm going to attempt to draw a protractor. I don't want that. Let's delete that. Attempt to draw a protractor. Protractor. I don't know why I can never get the protractor to draw properly. No, I don't want a duplicate mirror. Finally got my protractor. Now we can move the protractor around. I'm going to put the center of the protractor on the spot on the mirror where the incident ray hits the mirror. And then I'm going to align it so that the 0 for the protractor would lie on the perpendicular to the surface. And now you can see my ray coming in hits the mirror at just over 40 degrees, and my ray reflected off the mirror leaves the mirror at just over 40 degrees, measured from the normal. Okay. If I change the angle with which the light hits the mirror, that will adjust those angles. So I'm going to move my protractor again and reline it up. So the center of the protractor back where the incident ray hits the mirror, and the protractor oriented so that the 0 is on the line perpendicular. So now you can see that, let's see, 30, 40, 50, I'm at about 50 degrees on my incident angle, and the same for my reflected angle. So leaving this behind, that brings us to the law of reflection. I think the law of reflection is quite possibly the easiest law in all of physics. The big trick to it is remembering that you have to measure relative to the normal. So here we have our reflective surface, and I've drawn a dotted line which is the normal to the surface. If this is my incident ray, then this would be the incoming angle, and this would be the reflected ray, so that would be the reflected angle. And the law of reflection tells us that the input angle has to equal the reflected angle. This law has to hold regardless of what you're reflecting off of. It could be a mirror, it could be your couch, it could be your pet. I don't care. Any reflection has to follow the law of reflection. But different things do reflect differently. Certainly a mirror looks different when you look in it than when you look at a couch, right? That's because there are two types of reflections. You can have a diffuse reflection, which would be like the one that comes from your couch. In that case, the light comes in. Every ray follows the law of reflection if you look at it. But because the surface is rough, light rays go off in any direction so that people in different areas of the room can both see the object that is being reflected. the object the light is reflecting off of. Okay. On the other hand, if I have something like a mirror, right, then the light comes in and it all reflects more or less parallel, which means if this is the only light source in the room, maybe it's like a laser pointer, though please don't shine a laser pointer in your eye. The light comes in, it reflects off. This person would be able to see it because it reflects into that person's eye. This person cannot. This object is known as a diffuse reflector, and the reflection would therefore be a diffuse reflection. This one is known as a specular reflector and results in a specular reflection. This is the end of this unit. In the next one, we are going to be covering spherical mirrors.